Hi, in today's video we'll be taking a look at Year 10 higher tier types of number and sequences. This is from the White Rose Maths website and it's a fantastic resource, okay, for Key Stage 1, Key Stage 2, Key Stage 3 and even Key Stage 4 maths as well. Okay, so it's even got revision stuff for year 11 actually, and in particular this year as well actually, as part of the summer actually. So it's got the Edexcel prediction papers for 2022, so feel free to obviously check that out guys on their website. This is question number 1. Match each sequence to the correct name. Okay, so the sequence 1, 1, 2, 3, 5. This is what I call a Fibonacci sequence. And basically the way it works is the next term in the sequence is made up by adding the previous two terms. So if you look here, 5 is equal to 3 plus 2, 3 equals 2 plus 1. Okay, and then the first term obviously it starts on 1 here. Obviously 1 plus nothing here, obviously. So the sequence would always have to start with 2 terms in order to work out the third term. Okay, so that's what we call a Fibonacci sequence. The next one, 1, 3, 5, 7, 9, was a sequence of odd numbers. It's going up in 2s, so it's what we call a linear sequence. Okay, and if you're interested, the nth term for that one is 2n minus 1, if you're interested. Okay, adding 2s each time, and then the difference is minus 1. Okay, the next one, 1, 3, 6, 10, 15. Well, I'm adding 2, then I'm adding 3, then I'm adding 4, then I'm adding 5, then I'm going to add 6, and the next one will be 21. Okay, this is what I call a sequence of triangular numbers. So I can make a triangle out of those numbers. Okay, that's leaving the last one to be 1, 4, 9, 16. These are all square numbers, and again, if you're interested, it follows the sequence n squared for that one. And this one, if you're interested, it's half n plus 1. This is question number 2. Here are the first 4 terms of an arithmetic sequence. Minus 5, 2, 9, 16. Well, it's going up by 7 each time. So I'm adding 7 each time. So it's going to be 7n. Okay. And to work out the difference, I would do 7 take away negative 5. Okay, which gives me positive 12. Okay, so it's 7n plus 12. Okay, or 12 plus 7n. Okay, either one is fine for that one. This is question number 3, guys. Write 72 as a product of its prime factors. Well, 72 decomposes, okay, into 8 and 9. Now, 9 is equal to 3 times 3, if you're interested. And then 8 decomposes into 4 and 2, and then 4 decomposes to 2 and 2. Okay, locking off the prime numbers by circling them. Okay, so 2 and 2. So all of these are what I call prime numbers. Okay, so it's going to be 2 times 2 times 2 times 3 times 3. Okay, 2 times 2 times 2 is 2 cubed, times 3, or I can write that as 2 squared. 3 squared, sorry, not 2 squared. So it's 2 to the power of 3 times 3 squared. Okay. This is the next question. The Venn diagram shows the prime factors of 72 and 28. Complete the Venn diagram. Well, 72 is equal to 2 times 2 times 2 times 3 times 3. Okay. So that's completing the Venn diagram, okay? The next part, what is the highest common factor of 72 and 28? Well, that's going to be the intersection of my circles. So it's going to be 2 times 2, which is 4. Okay, so it's the intersection, so it's this part here, okay? The intersection of the circles, 2 times 2, or 2 lots of 2, is equal to 4. The next one, what is the lowest common multiple of 7 and 28? Okay, so that's multiplying all the numbers in the Venn diagram. So it's 2 times 3 times 3 times 2 times 2 times 7. Okay, working this out, well, I'm going to get, so 2 cubed times 3 squared is 72. 72 times 7. Well, 2 sevens are 14. So 4 carry the 1. 7 sevens are 49. Add the 1, it's going to be 50. So the answer is 504. Okay, now a Venn diagram is a fantastic way of representing your prime factors. And for highest common factor, it will always be the intersection of the circles. And for the lowest common multiple, it will be everything in both circles being multiplied together. Okay. So timesing all the numbers together. Okay, this is question number 4, guys. Here are the rules for the nth term of 2 sequences. Sequence A is 3n plus 5. Sequence B is n brackets n plus 1. Show that the difference between the fifth terms of the sequence is 10. Okay, so if I sub in n equals 5 into sequence A, I get 3 lots of 5, which is 15. 15 plus 5 is equal to 20. So the fifth term in my sequence A is 20, and the fifth term in sequence B, well, again, subbing that into my expression, I get 5 lots of 5 plus 1, okay, so it's in a bracket. 5 plus 1 is 6. 6 times 5 is equal to 30. If I do 30 take away 20, I get the answer of 10. Okay, so I've therefore proved that the difference between the fifth terms of each sequence is equal to 10. When I sub n equals 5 in there, I get 3 times 5 is 15. Plus the 5 is 20, and when I sub 5 into here, I get 5 lots of 6, which is equal to 30. This is question number 5, guys. The first term of an arithmetic sequence is 2. The difference between each term actually is 1 plus 2 root 5. Work out the second and third term of sequence, giving an answer in A plus B root 5. So if I add 1 plus 2 root 5 actually, I'm going to get 3 plus 2 root 5 for my second term, and the third term, adding 1 plus 2 root 5 actually, I'm going to get 4 plus 4 root 5. Okay, so the second term is 3 plus 2 root 5, and the third term is equal to 4 plus 4 root 5. Okay, and I can't actually simplify these surds or these surd components because root 5 gives me a irrational number. So if you're interested, if I put it into a calculator, it will give me a numerical answer, but the question's asking me to give my answer in the form of A plus B root 5. So it's not wanting me to find the numerical value. These are what I call the exact values, okay, of my expressions for when n equals 2. Okay, so it's going up in 1 plus 2 root 5. Okay, so I'm adding on 1 plus 2 root 5 actually each time. Okay, I'm adding that on. Adding 1 plus plus 2 root 5. Okay, this is question number 6, guys. The first 4 terms of a quadratic sequence are shown. Find the next 2 terms in the sequence. Well, I'm adding 6, then I'm adding 10, then I'm adding 14, then I'm going to be adding 18. So that's going to give me the answer of 55. And then I'm going to be adding 22, which is going to give me 77. Okay, if I'm not mistaken. Find an expression in terms of n for the nth term of this sequence. Well, the first difference is 6. Okay, the second difference is 10. Okay, so each time I'm increasing the difference by 4, if that makes sense. Adding 14, then I'm adding 18, then I'm adding 22. Okay. So, if I'm finding the expression in terms of n for the nth term, I've got to work out the second difference. It's going to be plus 4, plus 4. Okay. Okay, for that. Okay, to work out the values, okay, for the expression an squared plus bn plus c. Now, I'm going to be giving you some formulas here to actually remember. So you might be thinking, well, how on earth did I get these? Okay, but I have done a video on how to generate these expressions. But the idea is that 2a is equal to the second difference, which is 4. 3a plus b is equal to the first difference, okay, which is equal to 6. And lastly, a plus b plus c is equal to 7. Okay, and I've got to work out what my values a, b, and c are by solving each equation respectively and subbing the values into the next equation is equal to 7. Okay, so 2a is equal to 4. That tells me that a has to equal 2 straight away. So a equals 2. Putting 2 into here, 3 lots of 2 is 6 plus b is 6. B is going to equal 0. A is equal to 2. 2 plus 0 is 2 plus c has to equal 7. Therefore, c is equal to 5. So my final answer will be 2n squared. Take away 5. Okay.